Hey everyone, today we're breaking down one of the most powerful techniques in software engineering, caching. It's the secret behind why your favorite apps feel lightning fast. Whether you're building a small side project or a massive distributed system, caching is a game changer. Let's get into it. So what exactly is caching? It's the practice of storing copies of frequently accessed data in a faster storage layer, so future requests can be served quicker. Instead of hitting your database or making an expensive API call every single time, you check the cache first. If the data is there, you return it instantly. This is called a cache hit. If not, that's a cache miss, and you fetch it from the original source. Let's walk through how a cache-aside request actually flows. First, the client sends a request to your app server. The app server checks the cache. If it's a hit, the cache data is returned instantly. If it's a miss, the app queries the database, writes the result back into the cache for next time, and then returns the response to the client. This whole process is what makes caching so powerful. Without caching, every single request goes straight to your database. Your user asks for their profile, database query. They refresh the page, same database query again. Multiply that by thousands of users, and your database is drowning. Response times go up, costs go up, and eventually things start breaking. With caching, the app server checks the cache first. If the data is already stored there, boom, instant response. No database query needed. The database only gets hit on cache misses, which dramatically reduces load. Your app becomes faster, your database stays healthy, and your users are happy. There are several caching strategies you should know. Cache-aside is the most common. Your app checks the cache and falls back to the database on a miss. Write-through writes to both the cache and database at the same time, keeping them in sync. Write-behind writes to the cache first and asynchronously updates the database later for better write performance. And read-through has the cache itself fetch from the database on a miss. Caches have limited memory, so you need eviction policies to decide what gets removed when the cache is full. LRU, least recently used, kicks out the item that hasn't been accessed in the longest time. LFU, least frequently used, removes the item accessed the fewest times. FIFO, first in first out, evicts the oldest item. And TTL-based expiration automatically removes items after a set time period. But what happens when your cache goes down? This is called a cache stampede or a thundering herd. Suddenly, every request hits the database directly, and your DB gets overwhelmed. The solution is to build in fallback strategies. You can use circuit breakers to limit DB load, stale while revalidate to serve expired data while refreshing, or a multi-tier cache, so if Redis goes down, you still have a local in-memory cache. As your application grows, a single cache node won't be enough. You need to scale your cache layer. You start with a single Redis instance. Then you add RED replicas for higher RED throughput. Finally, you shard your cache across a Redis cluster, partitioning data by key hash. Each shard handles a portion of the key space, giving you linear scalability. Let's look at the real numbers. After adding a caching layer, latency drops from 850 milliseconds at the 99th percentile down to just 45 milliseconds. Cache hit rate climbs to over 94%, and database load drops from 95% to just 20%. These aren't theoretical numbers. This is what you see in production systems at scale. In a global application, your caching architecture spans multiple regions. Your origin in US East has the primary Redis cluster and the main database. Edge regions in Europe and Asia each have their own local Redis cache and CDN edge nodes. User requests are served from the nearest cache. If the local cache misses, it falls back to the origin. This multi-tier approach gives you sub-10 millisecond reads worldwide. Caching happens at multiple levels in your application stack. At the browser level, HTTP caching stores static assets locally. CDN caching distributes content across edge servers worldwide. Application-level caching stores computed results in memory. And database caching uses query caches and buffer pools to speed up repeated queries. Each layer reduces latency further. In a real production system, caching is everywhere. The client layer has browser and local caches. The CDN layer caches static files at the edge. Your application layer uses Redis or Memcached for session data, API responses, and computed results. And at the database layer, you've got query caches and red replicas. Every layer shaves off latency. Here's a simple cache-aside pattern using Redis in Node.js. When a request comes in, we first check Redis for the cache data. If it's there, we return it immediately. If not, we query the database, store the result in Redis with a 1-hour TTL, and then return it. Next time the same data is requested, it comes from Redis in under a millisecond. When it comes to caching tools, Redis is the king. It's an in-memory data store that supports strings, hashes, lists, sets, and more. Memcached is simpler and great for straightforward key-value caching. Varnish is a powerful HTTP reverse proxy cache. And CDNs like Cloudflare and CloudFront handle caching at the edge for global performance. The performance difference is staggering. A typical database query takes 10 to 100 milliseconds. A Redis cache lookup takes less than 1 millisecond. That's up to a 100x speedup. And it's not just about speed. Caching reduces database load by 80% or more, which means lower costs and better scalability across the board. And that's caching explained. It's one of the most impactful optimizations you can make to any system. If you found this helpful, hit that like button and subscribe for more system design content. Drop a comment telling me what topic you want next. See you in the next one.